Good morning. Morning. I tried to scare everyone off with the console mode debugger on the screen. That clearly did not work really well as advertised. My name is Chris Jackson. I am often known as the AppCompat guy. I've been working in the world of AppCompat for Windows, for IE, since 2006 or so. Done quite a bit of work actually here in New Zealand as well. My scope of influence is the planet Earth, so I don't do any interplanetary work. I'll be doing a 100% demo presenting without a net today. There will not be a single PowerPoint slide, not even the walk-in slide, as I'm sure you noticed. What you may or may not know is that the PowerPoint team actually charges you a tax when you don't use PowerPoint. I don't have any money, so in order to fund that, I've had to go to an advertising-based model. So I'd like to first start off with this advertisement for Windows 8.
Years and years ago, in 2005, computers used to look like this. Back when I was 1 year old. Look at this thing. It weighs way more than me. With Windows 8, my surface looked this small. And it is so much more powerful. And it also features mandatory integrity control. That's one of UAC for all your non-hackers out there. And keep me safe when people try to hack me. I had my credit card number stolen 5 times. I wouldn't have a credit card. Now I'm protected by application isolation. It keeps me safe when I run my Windows 8 apps. There's lots of bad hackers out there. Someone's trying to hack me. I'm a genius hacker. I'm a hacky good player. Own it. That's what I'm talking about. Windows 8. It is made of pure awesome sauce. Yankee, awesome sauce. I want you to pack my good player.
Thank you for rewarding child labor. So actually, I have gotten some feedback that really some PowerPoints would help. I actually got that feedback in some reviews. So I figured I would accommodate that request in the nerdiest possible way. So let's start PowerPoint in the normal way. We'll just set a breakpoint on user 32, bang, set window text W, and we'll just go ahead and do an update directly to the contents where the EAX register is pointing to. This is how you start PowerPoint, right? And we'll just do untitled, because we want a new deck, PowerPoint, and close that off. And we'll disable the breakpoint, and we'll go conditionally, just like you normally do. And now we have PowerPoint. And so let's briefly go over what we're going to talk about today, because security is one of those really, really big, broad words that could mean all kinds of things. And I want to be clear on what we're talking about. We're not talking about antivirus. We're not talking about firewalls. We're not talking about all of these higher order product level things. We're talking about the internals and really trying to deep dive into the technologies that enable us to have application isolation, as referenced by my lovely daughter, to really help to protect you and build a trusted application experience. So to do that, we're going to be going all the way back to UAC fundamentals, because it's my experience that no one really understands it, as I'll show you from some code that's still shipping in Windows that evidences that someone clearly who works on the Windows team doesn't completely understand it. We're going to talk about tokens and elevated tokens. Do some review. I understand a lot of you probably know an awful lot about UAC and about tokens, but there are plenty of you who don't. If you look to your right, look to your left, one of those guys probably doesn't. Here's a hint, it's the guy to your right. We're then going to talk about integrity levels and review what exactly that means and how that impacts it. And we're going to talk about UIPI, or user interface privilege isolation. This is all fundamental. It's been around for a while. We're just going to review it and make sure that everyone knows all the subtleties of it. Then we're going to talk about things that are new capabilities in Windows 8. Capabilities and how that affects your ability to do your security and app container, SIDS. And we will also mention briefly, although I've got Taylor, that's not right, container, the child app container, which is the one new thing in Windows 8.1. Is that what you think you came here to hear about? If not, there's lots of people who'd love your seat. But I just wanted to start off because there are so many possible definitions to make sure we all understand precisely what it is that we're trying to do. So let's go ahead and let's get a new command line window open and take a look at my token. And what I'll also do is, by the way, Windows 8 and 8.1, Windows X brings this nice convenient little shortcut menu to start your elevated command prompts from. Who am I is a command that will show your token. What are all the group memberships that you belong to? We'll go ahead and dump them out. Conveniently, I am connected through direct access. So this is an unintended direct access demo as I reach out across a very large ocean to try and figure out who I am. It's going to dump out the contents of those two tokens. Until it does, the one thing you will notice is that they are both two different versions of me. They have the exact same SID. Windows is the one and only commercial operating system where you have multiple versions of the same you. Typically, you go to Linux, Unix, Mac OS X, or Windows prior to Windows Vista, and you would have you and you with your elevated account. So on Unix derivatives, that would be root. On Windows, it would be the administrator, or typically on Windows XP and earlier, everyone who works at your company. And now we have two different flavors of the same you. And wow, this is taking a really irritatingly long time. So I'm going to shortcut the who am I command line argument and get a little bit less geeky and just pull open a quick token here. Here is a hi ilcmd.exe, and I'll just look at the security tab here. And here is, whoops, a medium il. And what we'll do, we'll use the Windows key shortcuts, Windows left arrow and Windows right arrow to bring them side by side. And we can start to look at the differences between the two. Both of them are me. They have the exact same identical SID. But where things begin to differ is, hey, built-in administrators, one of them just says, hey, you're the owner, and the other one says deny. This is a construct known as the deny only flag, which means I can only use my membership in the administrators group to be denied access to something, not to be granted. I mention this because I still get questions. I have administrators in my token. Why can't I just write to program files? Because write is an allow operation, and you have the deny only flag set. As I scroll through the rest, I still have all of my other group memberships, which for me is entirely too many, means I have too much work to do. But the privileges down below is the next area where things differ pretty dramatically. So when you conceptualize what does it mean to be a standard user, one rule of thumb that I found works really well. A standard user gets to hork all of their own stuff. An administrator gets to hork other people's stuff. Right? And with that rule, you can actually infer just about everything you need to do to get the job done. Program files is shared, so if I can write there, I can hork somebody else, and that's not cool, so that's why you can't write there. My documents belongs to me. If I hork it, I'm horking my own stuff. No one but me is going to notice, so that is allowed. A privilege is what opts me out of that particular rule. You have the privilege of going past this boundary. And a lot of the ones that you get by default make a whole lot of sense. The undock privilege. I have the ability to undock my computer. That clearly affects other users of the computer because the computer is about to walk away. But if I can't undock my computer, I don't really have a usable laptop for someone who I want to make as a standard user. So we just allow that. If I don't have the ability to shut down my computer, everyone's computer is just going to be on all the time. So we allow that, even though that clearly also affects other users of the computer because the thing is no longer on. Something we added for Windows Vista is the time zone privilege, because On Windows XP, if you ran as a standard user, you couldn't switch time zones at all because we had tied time zones together with system time. System time remains an administrator privilege. And there is a system time privilege, and it still is part of your administrator token for a couple of reasons. One of them is you can cause denial of service if you can change the system time. The ability to log into the computer depends upon you being within a certain tolerance of the time on the server for Kerberos authentication. So I just changed the time, and suddenly other people can't log in. More importantly, it also violates the repudiability principle, which says I can change the system time, do something naughty, so the audit logs say I did something naughty between 10 and 11 p.m., and then go be visibly at a party where there are no computers present, and then I have plausible deniability. I wasn't actually there, so we don't allow standard users to change the time for very good reason. So we've separated that out, and we've said these things, they are technically violations, but without the ability that you do these things, the computer is not really fully usable, and that's how we divide things up. So two different me's with two different sets of privileges. So the question is, how do those me's come to be, and what does that architecture mean? In WinLogon, we go through and we create the elevated process and the elevated token, and then we go through and we create a filtered token, and then we launch, we create process explorer.exe using that filtered token. And the way tokens work on Windows is that you inherit your token from your parent process. Most applications get started from Windows Explorer, so they'll just inherit Windows Explorer's process. A consequence of this architecture. Two different logons. There are two different logon sessions, different from terminal services sessions. Here at Microsoft, we love to use the same word over and over and over again. Just look at virtualization. Logon sessions, we have two of them. And it turns out that we store mapped network drives with your logon session. That's why if you elevate, suddenly you can't see your mapped drives anymore because typically they're run in a logon script run as U. That's always been true, and you can actually try it on Windows XP, do a run as, put in your own credentials, and run CMD and go looking for them. They're not there either. It's always been true. The difference is now you do it most of the time if you're running as admin. It's fairly natural, whereas on XP you'd have to be a little bit crazy to just go through and log on as yourself a second time. No one really did that. So it's just a difference in frequency, not a change in architecture, but it's an unintended consequence. So that's how we do baseline elevation. The next question is, how do you go through and elevate a process, and what are the ramifications there? Well, the first thing is you have to go through shell execute in order to create an elevated process. You cannot go through create process. The reason why is that we've re-architected Windows into a series of layers. And the rules are you can depend on anything in your layer or below, but you cannot go up. That's not allowed. Create process is really fundamental to Windows. You cannot run any code unless you have a thread, and threads live inside of a process. So without create process, you really can't do anything. So it's in layer 0, as you might imagine. Elevation requires a window manager. You can do all kinds of things without a window manager. You can, in fact, be a fully shipping SKU of Windows called Server Core without a window manager. So therefore, elevation and its window manager dependency for the elevation process cannot be a dependency of create process in layer 0. So create process goes into a service, which is the app info service. You can actually go and look at it in the services at MSC. It calls into consent.exe. And if you say yes, then it will call create process as user using that filtered token and then reparent it so it looks as if the calling process is the one that launched it. Consequence of that architecturally, which I very seldom see but have noticed, is that you also inherit your process environment block from your parent process. And if you are trying to pass information to an elevated process by setting some environment variables, they don't get there because the environment variables come from the parent process, which is the app info service. Right? All these little unintended consequences, which is why I usually spend the time to learn the architecture. Why did we build it the way that it did? When we think about elevation, it also behooves us to think about what kind of elevation would we actually be doing. And there are a couple of different options. I know Alan Birchall is really happy right now because I just pulled open the group policy console. He's the group policy guy. We're doing a presentation tomorrow, so he'll be driving group policy for me tomorrow. I'd say I have to actually do my own. Talk about a low-rent conference. But when you think about elevation, what does it mean? Well, if I'm an administrator, I'm just elevating myself, and there are plenty of roles in which that makes sense. I will say that from the perspective of the application ecosystem, UAC has done more good to create more applications that actually function as a standard user than we ever imagined. Like, that was our design goal, and we actually achieved it. It's actually fairly hard to buy software that doesn't work with UAC enabled today. It's not impossible. There's some sort of boutique industries wherein they say, step 1, turn off UAC, step 2, install our software. I still see that. I have had 2 installer packages so far that actually helpfully go ahead and turn off UAC for you as part of the installation process. I love that. But for administrators, it works really well, and the default today is to simply prompt for consent for non-Windows binaries. It's the minimize annoyance, because believe it or not, UAC prompts were the #1 source of customer issues on Windows Vista. Can you imagine? Who would have thunk? So we address that by saying some tasks, like opening the group policy editor, that are clearly administering the computer will not require a prompt, but others will. And it's actually, this is a little bit of a simplification. The Windows binaries have to be manifested, and as part of the Windows build process, to include that bit of the manifest, you have to demonstrate that you don't accept command line arguments, so it couldn't be driven by the bad guy. Those are the actual rules in the Windows build process. For those who hate prompts and never want to see one again for the rest of their lives, there is the option to elevate without prompting, and you'll never see a prompt, but you don't turn UAC off. And you also have the option to make you type your credentials if you really want to. I've never met anyone sane who actually does that. And I'll point out, by the way, you can search for the configuration of UAC by just looking for the word prompt. And if you turn it all the way down on Windows 8, this does not turn UAC off anymore. All the way down says auto approve, which is different from how it behaved on the slider on Windows 7. And as we continue to talk about Windows 8 apps, right, the reason why is that Windows 8 apps don't work without UAC turned on. So making it really easy for you to break all of your apps was really kind of not in our design goals. So we fixed it that way. So that's for administrators, which is what we normally think about, because most of us are probably administrators on at least some of our machines, I'm assuming, right? If you're in this room, right, there's a console mode debugger welcoming you, so you have to be a bit of a nerd, so you're probably an administrator on some of them. What we need to think about is, what do I do for my standard users? The other guys. How do I handle elevation for them? And for me, it's one simple question. How am I going to get administrator privileges on their machine remotely when I'm trying to help them? Because unless you just have such a plethora of IT staff that you have people wandering the halls looking for people raising their hand asking for assistance, they'll probably have some kind of help desk system in place where people call up and they'll need to do something on that computer. How are they going to do that? Are you going to have them remote desktop in and do the work in their own session on which they're an administrator? Or do you want to have them do it interactively with the user in the same session? Because the difference really determines how you're going to configure your policies. If you are going to have them log in as a completely different account, then you can simply auto-deny. This generally tends to reduce help desk calls, because it just says, running this program has been forbidden by policy, which usually scares people enough they don't call the help desk to go, what's wrong with this policy? They usually say, oh, policy, ooh, that sounds dangerous. Let's not do that. The other option I have is to prompt for credentials, which is where I would have to have it typed in. We default to prompt for credentials. That's a consumer setting. That's what we do in my house. When one of my kids raises their hands because my kids are no longer admins. By the way, UAC helped make games that no longer require admin rights. Try buying one from 2005. They didn't really make them that didn't require admin rights at the time. But if they have something that needs done, they can call me over. That's a consumer setting. Not so much in the enterprise. Right? But if I want the help desk to enter them, it does generally tend to get a bit more help desk volume, but now I have an ability to do that. But I need to combine that with other settings because most remote desktop software doesn't remote the secure desktop. So I often have to turn off the secure desktop in order to get that software to work. In fact, the only application I know for remote access that doesn't require me to switch that policy is msra.exe. There is a policy in there that says, hey, I want to allow my UI access applications to prompt for elevation without using the secure desktop. This is one of the best named group policies ever. I have subsequently determined that the way we name group policies at Microsoft is we get a bunch of guys in a room, they just take their face and they bang it against their keyboard, and whatever English words come out are what we use. Let me, I mean, everyone's clapping. I think I hit a chord there, right? Let me translate this from group policy language to English. Allow msra.exe, which is using undocumented internal APIs to achieve this, to prompt for elevation without using the secure desktop. And that's what that means. So if you're using MSRA, you're good. If not, if you want to do remote elevation, you typically have to turn the secure desktop off. So that's elevation. The question is, when does elevation happen? And go ahead and exit that. See, it actually finished 5 minutes too late. So it's not helpful, therefore. Let's go ahead and start Compatibility Administrator. Boy, that's loud. Let's turn that down. Oh, the video's over. There's no more videos. We could just sit and watch movies the whole time, I guess, but I'm told that's not okay. So we'll give that a minute to load up because it's all encoded there. There is a widespread perception that elevation happens because we've detected that you are doing something that requires it. I've heard some people who believe that elevation happens because you're using a protected API. It doesn't happen at that level. Elevation happens when you launch a process, because once you have an elevated token inside of that process, it's accessible to every other thread in that process, and therefore it would no longer be secure. So you are always starting a new process after you see a UAC prompt, assuming you say yes. So we've got to figure out, before we even launch you, if you need it. Now, if we wanted to make app startup time really delayed, we could try and reverse engineer whether it's necessary, but we don't. We have to use some good guessing. And the guessing we do is based upon some data. Did the developer tell us that they need it? Because they can via an application manifest, and therefore we'll do whatever the developer asked us to do. If they said require administrator, we'll prompt. Did the IT pro go in and apply a fix such as run as admin, which causes me to elevate, or run as highest, the really confusing one that says if I'm an admin, put a prompt, but if I'm a standard user, don't. Or if I'm somewhere in between, put a prompt. That one's kind of a confusing one, but basically it's for legacy reasons. So if someone knows, that's really easy. But we had to figure out, how do we solve the rest, all the ones that we don't know about? And the big problem was setup applications. So how do we look for them? We just look for things like an internal name in the string table with setup, the original file name of setup, the file description includes setup, right? So wildcard. This, of course, is this full width katakana. That's set to uppu. I'm not kidding. Product name, company name, or if just it has the word setup in there at all, will think you're a setup. And there are 4 different things we look for: setup, update, star update. Go back home, I can look for patch. Oops. Right, star patch. Or listed under installer detection, INSTAL. If we find those strings in your binary, we'll think you're a setup and we'll automatically add a prompt for you, helpfully. And we're often right, but we're not always right. This was actually one of the final escalations we did before we shipped Windows Vista, was in Best Buy, which is a computer store in the US. They have a little application that runs on every single computer in every single store they have that had an updater program to update its content that had the word update, and consequently it was prompting. They don't run their display computers as admin, as you might imagine, so it was breaking it, and this was the reason, was the installer detection. It's also kind of interesting because I worked with one particular organization, part of a company called Flexera. That little division was called Install Shield. It turns out absolutely everything they used triggered installer detection because it was the name of their company. But that's why it happens. The developer asks for it, the IT pro asks for it, or we think you're a setup. The way to get out of it, if we've guessed wrong, you could turn the feature off, although it turns out to be really helpful, and usually people end up sad turning the feature off, is to specifically put in the specific non-installer flag via a shim database to say, nope, this is not an installer. You could also go in and add your own application manifest. But when you do that, you will turn off other fixes that UAC provides. So your application will probably end up more broken as a result of doing it than it would if you had simply applied this flag. So that's elevation, and that's why it happens. That's sort of fundamental. That's the baseline. We need to have this concept of the token and the security token in place. Elevation, UAC, that's fundamental. On top of that lies this concept of integrity levels. Let's see. Oh, good. I did put that in my path. I'm just making sure. All right. So what I'm going to do is I'm going to use the PS. I'm going to clear the screen so you can actually see it. And I'm going to do a live zoom. Because unlike Scott Guthrie, I will actually use Zoom It instead of the Windows magnifier. By the way, I did send a note to Mark Rusinovich, who sent a nastygram to Scott saying, why aren't you using Zoom It? He helpfully copied me on that, so let's see if I still have a job at the end of this trip. PS exec, a sysinternals tool that allows me to start a process. I'm just going to start it locally, and I'm going to start it with the low integrity flag, which means now I have launched Notepad, and it's running in low integrity. And I can see that using another sysinternals tool, which is Process Explorer. Pick the window. Here it is, Notepad. It is running in low integrity. So let's briefly say what integrities are, and then we'll show what they are. Integrity levels are the way to do security checks based upon how much you trust a process, not just based upon who you are. And while there are multiple different levels beyond this, really, if you think of there being 4, that gets you most of the way there. Low integrity is an untrusted process. Medium integrity is a standard user process. High integrity is an administrator process. System integrity is for services, typically. There are a couple of additional ones. There's one between medium and high that we use when you're a UI access application, so that we can try and isolate you using UIPI for that. You can, if you are, I just repaved this machine. There's another application, another web browser you may have heard of. It uses a little circular logo with multiple colors on it that look like our colors. It uses what's called untrusted, which is an integrity level of 0. Technically, integrity level is a 32-bit number, which means there are 4 billion different possibilities. We've found use for about 6 so far, so we've got a lot of room to grow. This is running at low integrity. Now let's see what that means. So from this low integrity process, I'm going to go ahead and say this is written at low, and go ahead and try to save it. And we'll just put it into my documents. And this is where you learn that you should never trust error messages. We can't save it. Oh, that's SkyDrive. That's not where I want to put it. Let's put it in Documents. Let's try this again. Test.txt in Documents. And once again, we'll learn, don't trust error messages. You can't write to Documents. Would you like to save it in Documents instead? I would. Let's try that. Good advice. Error messages tend to lie. It's not allowed to write there. They never imagine that some nut job would come up and run Notepad at low integrity. So the real question then becomes, what's that check being done against? So if I go into my documents and I create a new text document, and I'll just call it, let's call it file.txt. And open it. Yeah, let's not bother saving that. We'll go into Documents, file.txt. Aha, I can open it. Your integrity level is mapped up against an integrity label. Every securable resource has that label, which marks not only your level, but what you're allowed to do from 3 choices. No read up, no write up, no execute up. The default on every single file you don't mark is medium, no write up. So this one's medium, no write up means I can read it, but I can't write to it. So if I tried to save the one I just opened, I would get, hey, you can't do that. It's going to try and pop it somewhere else. You can change this. I'm going to use a utility written by Mark Manassi, so full credit. He's the guy who wrote it. I'm too lazy. Let me get into Documents. CHML, file.txt, and I'm going to mark it as low integrity. Now I've changed the label. So if I look at it, I have integrity level of low, and my policies are no write-up is enabled, but there's nothing below except for that other web browser I mentioned that no one actually uses, I don't think. Test from low. Now I can save, because now I've relabeled it. So now I'm starting to make differential decisions for my different processes based upon level of trust of the process. Right? All very fundamental. I can change that to do all kinds of other policies, but that level of trust-based auth is new. It's built right into the access check mechanisms of Windows. On top of that, we also have this concept of user interface privilege isolation, or UIPI. And to demonstrate that, I'll quickly kind of show, for those of you who don't remember the days when we used to write Petzold style C. In fact, there's probably a fair number of non-developers in the audience altogether, because I don't think I'm in a dev track, so shame on me for showing so much dev stuff. But this is actually really cross-boundary stuff that affects everybody. If you've never seen how Windows works, I'm using a tool that comes as part of Visual Studio called Spy++. We think of Windows working in terms of objects and properties, but it doesn't work like that. Windows is a message-driven architecture. You move the mouse, it sends a message to the program your mouse is on top of, hey, the mouse moved, in case you care. Every single time you push a button, it sends a message, hey, the button went down, hey, the button went up, and which button it was. You push keyboard strokes, and it sends messages, hey, the key went down, and it was this key, and the key went up, and it was this key. If you want to get the contents of an edit control or anything on there, you have to send a message saying, I'd like to know what's in you, and it will send a message back saying, here's what it is. That's how Windows works at a very fundamental level. Windows messages do not have security descriptors. So anyone can send a window message to anyone else. Use a find window API. Find me a window called this, and then send this message to it. Or I can just enumerate all of them and spray it on everybody, and there's no restriction. Windows does not have the concept of authentic user gestures, so we cannot tell the difference between a window message sourced from a physical hardware device and a window message sourced from a program that's trying to simulate that device. Good if you're doing UI automation, not so good from a security perspective if you're worried about someone driving it. And the introduction of multiple levels of trust highlights this as a bit of a problem. If you're in this low-level of trust, you can't get to resources, but you're sitting on a desktop with a medium-level Explorer.exe with a well-known set of windows. What are you going to do? UI automation to Explorer and do whatever you want to and break out of your jail cell. So we stop that by saying, when you are sending window messages, we have a filter that checks the calling process and the receiving process. If the calling process is greater than or less than the receiving process, the message is not sent. Never gets there. So we'll go ahead and show you the consequence of that. So here is an application, and it's using a design paradigm that used to be really common. It's creating an out-of-process COM component for the nerds out there. How many of you are devs, actually? Do we have any? Got a handful. So for you four, it's an out-of-process COM component that we just, since it's out of process, we can elevate it using the COM elevation moniker, but then we're building the UI directly from the calling process, which is a medium IL process. Since this is medium IL, this allows me to use automation to do whatever the attacker wants to do. Boop, hijacker, and there you go. And now I've made my new user, and I've driven that, and no one's the wiser except for this giant red box in the middle of your screen. UIPI is designed to protect against that. So if I design things correctly, I will have this child window, which is conveniently annotated in bold red. This child window, oh, come on, don't scroll away from me, is a high integrity process. And as a high integrity process, the attacker is running at medium. He's running as a standard user. He can't get in there. Because those window messages are just boop, never delivered. No notification to the calling program, how it went, is just completely gone. So now we've prevented that backdoor from being exploited as well to help. All part of defense in depth. Incidentally, since we have a lot of IT pros in the room, if you've ever done this, drag and drop onto a command line, elevated command prompt, drag and drop and nothing happens. How do you think drag and drop works? Window messages. That's UIPI stopping you from doing drag and drop. And if you then say, oh, well, I'll just launch Explorer.exe as an admin and get past that, Explorer.exe is single instanced. So we'll actually check and go, hey, there's a new Explorer. I already have one. Let's just go ahead and navigate a window to the window you asked for and kill off this new process. Elevate or not, doesn't matter. So it looks like it worked. A new window pops up, and it will not be a new Explorer.exe. You used to be able to, on Windows 7, you could right-click in an area of the Start menu and say Exit Explorer. I think it was a Control-Shift right-click, and you would cleanly exit instead of just going and just kneecapping the process. There kind of is no Start button right now, right? I don't see an End Explorer or Control-Shift. I can try that. Yeah, we don't really have any sort of clean way to kill Explorer, so now you just got to kneecap it again if you want to kill off Explorer and get an elevated one, which is a terrible idea, so don't do that. So, UAC, multiple credentials. We've got all of this security around levels of trust, and this is the foundation upon which we started with Windows 8 application isolation. Right? So we're, what, 2/3 of the way in, and we've just covered Windows Vista. This is how revolutionary Windows Vista was. If you think that like all of that was really fundamental, this fascinates me. Remember how I said changing the system time is an admin operation? So this dialog is something administrators could do. What's it running as? Developers on the Windows team are still getting their heads around UAC, which is why I'm still talking about it. This stuff really is hard. It's very new, it's very different, and there's all kinds of subtleties. So that's why we're still talking about it. So that's the foundation. Every single Windows Store app is going to run at low integrity. That's the baseline. The problem with low integrity is that it's not enough. On Windows Vista, there was one and only one app that I could name that ran at low integrity, and that was Internet Explorer in what we call protected mode. There was nothing else, so it was by itself, no problem. And then more people started writing low integrity apps. So now you've got Internet Explorer as well as Google Chrome running in low integrity, although Chrome is running at untrusted, which is a 0 integrity, versus, what is it, 4096. I can actually go and look at this. So here's a low integrity iExplore.exe. It's just a SID S1164096, which is the low label. So it's at S1160 is what Chrome runs as. Microsoft Office 2010 and above, protected view is low integrity. So now I'm running Office down this little cesspool, right, when I have something that has Mark of the Web on it. Pull it from email, it's going to run there as well. And then you start throwing in other stuff. Adobe Reader 10. Every Adobe Reader 10 document opens in low integrity. And then every single Windows 8 app altogether. So if everyone's in the same cesspool, you're not helping protect anyone. They're all together. So we need to then figure out how do we put barriers between them to make that happen. So I'm going to do what's probably going to make some of you gasp and launch Visual Studio. Aha. We won't spend too much time going through the code. I'm using it as a launching pad, but I will explain briefly what the code is doing. It's in C++. You don't have to know it. It's perfectly okay. I did it because it lets me do absolutely everything. The first thing I'm going to do is just create something using the new WinRT APIs. Again, we love to rename things. WinRT, great name for an API, and for a surface. Why think of something new? We already got a name. So this is going to launch the application. It's going to helpfully load some symbols. I love it when that happens. Let's go ahead and cancel that because I really don't care if there are symbols. Oh no, you're really going to make me wait for the symbols in the middle of my demo. That's fantastic. And then you're going to crash. See, this is what you do when you present without a net. You get into situations like this. But as I always say, in my line of work, you never really have failed demos. You just have unplanned debugging demos. Okay, there we go. All right, let's launch it again. Let's see if we can do any better this time. Really? You're going to do it again? That's fantastic. All right, well, it's moving. So what we are doing in this case is we're just trying to open up a file. And what we're going to find is that we're in low integrity. The file is in my documents library, which, as I mentioned earlier, is medium no write-up, which means I shouldn't be allowed to write there. So that's a very interesting question. Is I can think of all kinds of scenarios when, from one of my Windows apps, I'd kind of like to save it someplace where I can find it. So how do we get out? So the way that we do that on Internet Explorer is we have a broker process. So every single tab in iExplore.exe runs in low integrity if it's in protected mode. But there's always a parent process which runs at medium. So if you wanted to save a picture from the web, technically you cannot write to your pictures library from iExplore.exe in a tab in the Internet Zone. Not allowed to. So how do we get around that? This parent process serves as a broker. So the child tab process says, hey, here's this picture. I'd kind of like to save it. The broker gets to enforce the rules. The rules that Internet Explorer chooses to enforce are the user has to pick the location so it's not a surprise. If you've written an ActiveX control that just tries to spray things over some of their directories, that's not going to work in protected mode. But if you just say, hey, let the user pick some place to put it, then the broker process will then take it and do the write itself and do the inter-process communication. Oh, really? I actually went through this whole thing to have everything cached, and it's not doing a really good job of caching things for me. Hopefully that won't take too long. Boy, this is really kind of blowing my groove here. Let's see if cancel helps this time. All right, well, let's just launch it directly. See if that does any better, because then I won't have a debugger attached. Of course not. By the way, in Windows 8.1, if you really want to kill something, just bring it down here and hold it, and it will eventually die off. How are we doing? All right, so now, let's see if this will launch now. Come on. There we go. Yay! If I go and try to write someplace directly, it's going to say you've got a problem. And the reason why is because it's trying to write to the documents directory. Oh, this is describing error reporting. That's really helpful. Yeah, don't bother setting that. It's trying to write to the documents directory, and it's not allowed to. And the way that the broker process works for Windows 8 apps is that it looks at what capabilities you've decided to give the application. And there is a documents library capability to say it's allowed to. So it will check. And by having the declared capabilities, it can notify the user when you're installing it, hey, this app is going to write to your documents library. It's going to hit your network. It's going to use your location. And you can decide whether or not you think that's OK for that app. So it's a way to sort of granularize trust and for you to declare, I'm going to possibly do these things. I'm going to be allowed to. Are you OK with that? So if I were to rebuild, oh, really? That's awesome. This is really not going well for me. If you were OK with that, you could declare that capability. Let's just go ahead and forget that we were doing a compile there. And I will work that out later and carry on looking at what's happening in the code. If I declared that capability, that would work. So what else might I do? Well, the next thing I did in code was to simply try to write directly to the documents library. And that's important. There's a difference. One of them is going through the WinRT APIs. That calls into the broker process. The other one's writing there directly. So if I try to write there directly, it's just going to come back and say, oh, access denied, error 5, you can't write there. So we know it's running at low integrity, and we can go and see that in Process Explorer. So we can scroll up and find file access.exe. It's running at low integrity. I can find this S1164096, low IL. So if I wanted to modify that to get it to work, I could go in and say, all right, let's get a command line window open here. And let's make, let's get the documents. And we'll rename this to sample2.txt or .dat. Yes, which is what it's going to be looking for. So I've pre-created it, right? The way that create file works is if you have an existing one, it'll go ahead and use the existing one. So here's the sample2. And what I'll do is I'll get around the same way I did for Notepad. I will get around it by simply granting access for low integrity. So I can just use CHML, sample2.dat, set it to low integrity, and see if that helps. So I go back over to my demo application, and I find that I still have error 5, access denied. So it's not just low integrity. Now we've got to start building up walls. Those walls are what we call the app container. So in addition to having integrity levels, we also have for each and every single Windows 8 application, let these guys resolve. and I just expand it and see it, we have an app container SID. Every single Windows 8 application has an identity now. For anyone who's ever had to do application inventory and try to reconcile when you have two different packages that are really the same app with two different names, knows how frustrating it is that apps don't have identity. Now they do. This app container SID is generated based upon a hash of the name that's provided. So from a Windows Store perspective, that's why people who are making Windows Store apps have to reserve the name of their apps, which we say use the name of the company or the developer, followed by the name of the app and the name of the subpart, whatever you want to do. But it has to be globally unique. We take a hash, and that hash becomes the app container SID, and we can use that for authorization. So it's because of this app container SID that we still can't write there directly. But what I could do is I could grant this app container permission to write there. So what I'll do, I'll just use iCackles, get sample2.dat, and I'll grant, and I am not going to type this, because the demo gods are not happy with me today, and grant full control to that app container. One isolated application. And now I can write to it. Clear this off, no more errors. So it is a combination of low integrity and a unique identity for every application. And incidentally, we also, to simplify things, if you intended something to be resourced by multiple different applications that are Windows 8 apps, you have the ability to go in and maybe if I just yanked the network, I would stop having to wait for everything. That should help. Or it will cause Explorer to die off on me. That's awesome. There is also a grouping that is all app containers. So I can choose to make it writable by every app container or by one specific app container. So Windows 8 apps are built on a platform of UAC, on top of which we have user interface privilege isolation built on top of mandatory integrity control. We then have app containers to begin to isolate them from each other. This is going swimmingly today. To start to build up that level of isolation. Now, I'm not on a network. There we go. Now I can go find it. Ha-ha. Demo rescued. If I look at all the names, go to advanced, and show me everything, I can see that there is a new all application packages. So I could put the one based upon a SID, or I could put all of them together. Incidentally, for those of you who are, the two of you who are developers, this may get some gears thinking of, hey, you know what, I've got an existing desktop app, it'd be kind of nice to be able to access that app from a Windows 8 app. I wonder if I could punch a hole to do that. Now, if you wanted to submit to the store, you can't do that. But for a side-loaded enterprise application, there are some options, and that's one of them if you needed to do some interaction with your existing software assets. This is how it's implemented. It's a detailed implementation, so I wouldn't build a long-term strategy on it, but it's actually how it works and how it's implemented today. So, back to the store certification, I mentioned before that we could add the My Documents capability and be able to write there. But we actually significantly restrict that. The purpose of the My Documents capability is not to let you just write to My Documents. The preferred way to do that is to simply go through and leverage the user. If I'm going through the Windows Runtime APIs that make the user choose which one I'm going to have, then I don't need to have the documents capability. I can save it. Let's not put it in SkyDrive. Let's put it on this PC in My Documents, and I can save it. And that one worked just fine because the user was involved. That's the same principle that IE uses. That's going through a process called runtimebroker.exe, and we can see that in Process Monitor. So if we launch Procmon, we'll go ahead and reset the filter. We'll go ahead and save this in Documents. We'll say Save, replace the existing one. Sure, go right ahead. And we go back over to Process Monitor. And stop monitoring, do a filter, and show me everything where the path contains sample3.dat. Right? Then we'll find, the search is trying to find it, so let's exclude that. Right? And I have this thing called picker host, which is what was doing the work for me, and this process is a medium integrity process. It's a broker. It's allowing me to get there. So I have isolated, I have a helper. The helper enforces rules. In addition to that, there's additional isolation beyond, which is when you go through and create other kernel mode objects, we want to isolate those as well. Because from your Windows 8 application, when you think about how some of these synchronization primitives work, I can create one in one of two namespaces. Global for the whole machine, or local for the whole session, the logon session. So literally, it's technically the terminal services session. It's scoped within there. And you can only have one per name. So if I create something with the name of something that another application would like to have, by default, the second application to open, unless it says only make a new one, will go ahead and open the existing one. It's something called namespace squatting. We wanted to prevent applications from doing that as well. So when you create an event and you just say, stick this guy into the local namespace, I can go ahead and change the lower pane to show me all of the handles. And I have an event here. Let me expand this a little bit. I called it my event, and you'll notice that what we did is we added a prefix, session/1, which is where it normally go, and this new container called app container named objects with the SID of the unique app container followed by the name. That was injected automatically. That's not in my code. In my code, all I said was, hey, give me an event and call it my event. Create event, my event. And it automatically got put into this own isolated directory to prevent yet another vector to go in and spy on other stuff. Again, more of the concept of isolation. And the one thing that we're adding for 8.1 is the concept of the child app container. Now, there aren't any apps that are out yet for me to show this to you, but the concept is this. What if you have a parent application that wants to create child applications? Think of something like Word. And in fact, Office is looking into whether this is appropriate for them, but they and Adobe and other sort of document editing apps are what this was designed for. The ability to have multiple child with one broker. That's not a full medium I/O broker. It's not a desktop app. It's a parent app that they can all work together to have multiple documents isolated from each other, but not isolated from Word as a construct. How do we do that? Well, that's what child app containers are for, so we can have that relationship between them. So we'll start to see that. When we do, I can show that, but that's conceptually what we're building. But everything else remains in place, and that's what we've put together to create application isolation in Windows 8. The interesting thing, as a result of all of this, built on top of UAC, is we try to make it really hard to turn off UAC. You still can if you really want to. In the group policies, you can go through and turn it off, right? It is the, enable it for all, enable administrator, forget the name. It's one of those group policy names. It's a terrible name, but basically it's the off switch. By group policy, you can still turn it off if you really want to. It's a bad idea because you'll lose all your Windows 8 apps. It's also a bad idea because I can tell you for a fact that there is not a single test in Microsoft, not one, that's done with UAC disabled. So we have no idea how it's going to behave. So with that, I'd like to thank, I've literally run myself out of time. But it was a great fun kind of going through this romp through all of the internals. For those of you who don't code, I hope you were okay with that. I tried to not spend too much time. And I hope it was useful. Thanks for coming.